Hello. Today we're going to be looking at integrals and area. Now, in this point in Calculus 1, you're moving past derivatives and functions. So when you have a function with its derivative, you're looking at slopes, and now with integrals, all we're looking at with this weird looking, squiggly line, it's area under the curve. And now, with these specific questions, and with most others, you're going to be in respect of x. So this is dx in respect to x. So sometimes you can have it as dy, but this is dx by dy, right? So this is a function where we're looking at the integral. This is our function here, and then these are our bounds. So this is our f of b, and this is our f of a, right? So I'll leave this back up here. Okay, so in this problem, it's asking us to find the area under the curve right here between f of a, between 0 and -2 of our function in respect to x. This is how to read integrals, right? So if we're looking at this picture here, we start at, I'll choose blue as our color. We start at 0, and we look at what's happening to this function between these 2 points. So we see that it goes up in the positive direction. We don't care what happens past this point, right? Because we're just looking at from 0 to -2, and then it goes all the way down here, right? So the area under this specific curve, this isn't a curve, this is a line. So the area under this line, we're gonna take the area and look at what's happening. So we have this portion here. We're looking at underneath, in respect to x, as we're looking at the x-axis to the function itself, right? So if we're just dealing with this little section here, we're going to have a small part here and a small little area down below. And now I highlighted this in blue because this is positive area, and then this right here is going to be negative area, right? And now for actually like calculating this, you can look at all these little tiny boxes themselves. I can't draw a box, I'm sorry, but you can look at any of these boxes and look at them as having a base and a height of 1. And sometimes they teach you in school is that this right here is a triangle, right? So you have a base and a height, and to calculate the area of a triangle, it's 1/2 base times height. Or a lot of the times, and you can calculate this too. So if you're trying to calculate the area of this little subsection from 0 to -1, break it up, because you have positive and negative area. You can't just take this whole section here and just calculate it. Break up the positive, break up the negative, and see what shapes you have. So the area is equal to 1/2, the base is 1, the height is 1, which is equal to 0.5, right? So you have positive 0.5 area up here, and then down here you have another rectangle, right, which has an area. So this is area 1, that's positive area, and then you have area 2, which is negative. You could do 1/2. The base in this is 1, and the height is 3. So we have 1, 2, 3. You see how we got 3 there, because each of these little cubicles are length 1. So we have a base of 1, we have a height of 3, which is equal to -1.5. Don't forget that negative, because we're in the negative region of x. And so the integral, basically the total area between 0 and -2 of our specific f of x in respect to x is equal to, right, we have to add these up, is -1. Okay? Alrighty, and then same with B, it's asking from 0 to 5. So instead of looking at this area here, we're going to go from 0 to 5, right? And this looks like an odd shape, but literally look at this and break everything up, okay? So we have one box here, one box here, one box here, one box here. You know, break up everything that you already know. These are all boxes with area 1, height of 1, and a base of 1. All right, we have another box here, another box here, and then you have triangles here, but we just calculated this area to be 0.5. So if we know this is 0.5, 0.5, this we don't quite know the area of this or this or this. It's all looking like little tiny sections, but you know, if we do exactly what we did before, and we know that this is height, base of 1, height of 3, we know that this area is the same as this area down here, and we calculated that before to be 1.5, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These two make up 1, so 10, 11, 12, 12.5. So this would be equal to 12.5. Just count everything you see. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 11, 11.5. Okay, I miscounted. So make sure you count. With looking at these functions with just pictures, you have to really make sure that you count every single square. But you have an actual function that would represent like something that you can actually take the integral of, so that you know it's very specific. That way you're not just counting, right? So yeah, hope this video was helpful. Have a nice day.